Welcome to the third video in this video series going through the entire standard quiz model for the AP Calculus AB Term 1 standard quiz. So this video is going to focus on the third question in there, which asks you to use your knowledge of trig to evaluate some trigonometric functions, given some information about other trig ratios, as well as the quadrant that the angle actually falls in. So we're going to work through each of these two questions as well as the plus question. So to start with, the first question, part A here, gives you a good outline for what you're going to be given. The question states that given cosine of theta equals 5 over x squared, and that 0 and pi over 2 bound theta, then we want to find cotangent of theta. So of course the information you're provided here gives you a little bit of a different piece. First and foremost, we're given and told that we're in quadrant 1 by being told that theta is between 0 and pi over 2. It's the same thing as saying between 0 and 90 degrees. Second, they tell us what cosine of theta is. So basically, given that information, we can construct a triangle that will represent this situation for the angle theta in quadrant 1, and then use that information to determine the cotangent. So basically, using the information we have, I'm going to start by drawing a quick little diagram here. So I'm going to start here. We're in quadrant 1. So I'm going to draw a right triangle in quadrant 1. So there is our angle theta. We're in quadrant 1. So again, we're between 0 and pi over 2. And from in there, it says cosine of theta equals 5 over x squared. So in thinking about this, if cosine equals 5 over x squared, of course cosine is adjacent over hypotenuse. You might know that from SOHCAHTOA. So the adjacent will be 5. The hypotenuse is going to be x squared. So we've got two sides of the 3 labeled for this right triangle, but we don't have that third side. And that third side is going to be essential because cotangent of theta is adjacent over opposite. So we're going to actually need that opposite side right over here. So to get there and to find that third side, we use the Pythagorean Theorem. I'm going to abbreviate it because, yeah. So to get the third side, we're going to call that third side a question mark just for a second. I usually do this in my head, which is why I'm calling it question mark instead of a more appropriate variable name. So the question mark squared plus 5 squared is going to be equal to the hypotenuse x squared squared. So that means that our third mystery side plus squared plus 25 is going to be equal to x to the fourth, and that's going to be enough for us to determine that our mystery side, the question mark, is going to be equal to the square root of x to the fourth minus 25. And you'll notice I'm not putting in plus or minus in this case. I'm going to let the quadrant part take care of that for us. So we'll just take care of everything there. So our third side is the square root of x to the fourth minus 25. So now we've got all that information, everything's labeled nicely, and being in quadrant 1 means that all 6 trig ratios are positive, so we don't even have to worry about sign really here from now on. What we do need to figure out, though, is what is cotangent of theta. That was the focus and the focal point of this entire question. So cotangent of theta, as we mentioned earlier, is the reciprocal of tangent, and since tangent is opposite over adjacent, cotangent is going to be adjacent over opposite. In fact, I should be using better abbreviations here. So adjacent over opposite. So to figure out and answer this question, we need to know what the adjacent and opposite are for our particular angle. And in looking up there, our adjacent is going to be 5, and our opposite is going to be the square root of x to the fourth minus 25. There is, in fact, the cotangent ratio for angle theta that we were looking for. Now, of course, there are multiple different ways you could write this answer. There often are. There's no way to simplify the square root of x to the fourth minus 25, but just so you know, it is possible to rationalize this, although I wouldn't recommend it. This is kind of a do it if you insist kind of thing, but you could multiply up and down by the square root of x to the fourth minus 25 and end up with this as your final answer. Both are perfectly acceptable, but we don't ask you to rationalize in here. It's unnecessary. We just want you to be able to get to the correct answer. And that is true, by the way, even on the AP exam itself. So there was part A. So pretty straightforward, as in quadrant 1, everything was pretty nice. For question B, or 3B in this case, it starts out pretty benignly by giving us an actual numeric ratio. It says, given that tangent of theta is 2/7 and that theta is between pi and 3 pi over 2. So basically, in this case, we've got a slightly different situation happening here. We're between pi and 3 pi over 2, which means that we're in quadrant 3 in this case, which means in our picture, if we're going to draw this accurately, drew that picture poorly. Good job, me. Basically, our angle is going to fall somewhere down here. So to help me set that up, I'm going to begin by drawing out my right triangle just like I did before. Now it says tangent of theta, in other words, opposite over adjacent, is going to be 2/7. So those sides would seem labeled accurately, but if you're thinking about this, if we're in quadrant 3, both the x and y coordinates should be negative, which means in a sense you could, if you didn't want to think about quadrants themselves or something like ASTC, you could literally just go through and label them both with negatives. That way we make sure that we're covering the sine in every single side length that we have in our triangle. And now, of course, you might say, hey, there's no way to have a -7 side length. Yeah, you're right, but this is like directional because of the fact that we're moving around the unit circle. So we're actually okay here. From there, just like we did before, we have that missing hypotenuse side, but we know that the hypotenuse squared is going to be equal to the side length squared plus the other side length squared. So in other words, if h squared, or hypotenuse squared, is equal to 4 plus 49, that's going to tell us that our hypotenuse is going to be root 53. Sounds like a nice place to drive. So we have root 53 for our hypotenuse. We've got everything labeled in our triangle. The only thing I didn't label was the angle, but I could go ahead and draw that right there and say that's our angle theta that we're talking about down there in quadrant 3. Now, though, our question is, of course, what ratio are we trying to evaluate? And this asks us to evaluate the sine of theta. Well, sine of theta is opposite over hypotenuse. So if you're looking for the traditional SOHCAHTOA acronym, it actually begins that. So sine opposite over hypotenuse. And so now we just need to look at what the opposite and hypotenuse are relative to that angle theta. So for our angle theta, opposite is going to be -2, and hypotenuse is going to be root 53. And there is our ratio. And notice in quadrant 3, sine of theta should in fact be negative, and we do in fact get a negative answer. Once again, though, just for those that are really into rationalizing the denominator, you could write this as -2 root 53 over 53. That would be fine too, but this is the answer that we're looking for, the one that's not rationalized. We don't need to waste your time doing it. So that takes us to the two normal questions that we're looking at. I do have one plus question on here that you can see really elevates things a little bit. So for our plus question, it says, given that secant of theta is the square root of x squared plus 5, and theta is between 0 and pi over 2, we are supposed to find sine of 2 theta. And you can see kind of some of the philosophy of these plus questions a little bit in here, because they give you a slightly more complicated ratio. In this case, we're giving you the square root of x squared plus 5, so that's kind of complicated. But then we also ask you to find sine of 2 theta, which is a much more complicated identity for us to have to know and remember, or else derive as you're working your way through. So in here, though, the first thing I note is, once again, you've been gifted an angle in quadrant 1, which is nice. In a sense, you could almost drop the entire axes, but I like having that coordinate system there. So we've got an angle theta in quadrant 1, and the secant of that angle is going to be this square root thing, this radical thing. So if you'll recall, secant of theta is the reciprocal of cosine, and since cosine is adjacent over hypotenuse, secant is going to have to be the hypotenuse over the adjacent. So what that's telling us is that our secant is going to be the square root of x squared plus 5 divided by the adjacent. And since we're just given a single radical as our ratio, you can assume it's over 1 for simplicity, and we'll just say that that is our ratio. With that in place, our hypotenuse is square root of x squared plus 5. Our adjacent is 1. We can once again use the Pythagorean Theorem to figure out this missing side, the mystery side that's over there. So if you go through and use the Pythagorean Theorem once more, which again, I do this in my head most of the time, but I'm trying to be as communicative as possible in these videos. If you use the Pythagorean Theorem, we'll get 1 squared plus that question mark squared is going to be equal to the square root of x squared plus 5 squared. When we solve that, we get 1 plus that missing thing squared is equal to x squared plus 5, and that means that our missing side is going to be x squared plus 4, or excuse me, our missing side squared is going to be x squared plus 4, which means our actual missing side is actually the square root of x squared plus 4, which is kind of interesting, for sure. So with that in mind, I can go ahead and label that up on my graph. So we actually have two fairly complicated radical sides to deal with, but that's okay. We've taken care of our triangle. We now have everything represented for theta as a function of x. Our issue now is that we now have to deal with the sine of 2 theta. So there's a couple different ways to get here. If you don't recall what the sine of 2 theta is, and you possibly recall some of the sum and difference identities, you could derive this by doing the sine of theta plus theta. That's certainly one possibility. Or you could just simply remember what the sine of 2 theta is. And sine of 2 theta has a nice ratio. It's 2 sine of theta cosine of theta. So what makes this a little bit more interesting is we have to find both sine and cosine in order to evaluate the sine of 2 theta. So this is just one of those identities that kind of pops up enough that it shows up a lot. It's called a double angle identity. From here, looking at all of our pieces, we now need to evaluate each part. So the two parts pretty easy. As far as sine is going to be opposite over hypotenuse. So opposite and hypotenuse from our triangle. It's going to be a ratio of two radicals. We get square root of x squared plus 4 over the square root of x squared plus 5. By the way, this is a good thing to see. X squared plus 4 and is always smaller than x squared plus 5, which is good because sine has to always be less than or equal to 1. And then finally for cosine, we get 1 over the square root of x squared plus 5. And then as far as simplifying this thing, the last little piece we'll have here, we'll get 2 square root of x squared plus 4, all divided by, since we have the square root of those things, so square root of x squared plus 5 squared, we'll get x squared plus 5. And there is the answer to the plus question, which again, I actually don't think was particularly difficult. It was really just knowing the identity. But that is something that could come up on a couple of these plus questions for number 3. So with that said, that goes through question number 3, focused on trig ratio evaluation.